So this one is a case 3 for getting the particular integral for a partial differential equation. Remember, last session, actually we are started homogeneous partial differential equation. So let me come to that. Just 1 minute. Homogeneous partial differential equation. So these homogeneous partial differential equations are of this form, like d square minus 4d d dash plus d dash square of y is equal to some f of xy. RHS is some function f of xy. So in general, the form is like phi of d comma d dash of y is equal to f of xy. This is the form of a homogeneous partial differential equation. Why it is a homogeneous? Because degree of each term is the same. So you'll observe d square is there, dd dash is there, d dash square is there. So degree of first term is 2, d into d dash is there. So that degree is also 2. So each term have the degree same. So if it is a d square minus d dash only, then it is not homogeneous because only d dash indicates the degree of that term is 1. Here degree of this term is 2 because d raised to 1 is there, d dash raised to 1 is there, 1 plus 1 that is 2. It's just like the algebraic equation, say x square plus xy plus y square. This is the equation whose degree is a 2 and it is homogeneous because degree of each term is 2. X square have the degree as a 2. This is a degree 2 and this is degree 2. So this homogeneous function you already familiar in last semester you learned this definition for using the Euler's theorem for partial derivatives. Okay, that time. So similar thing is here. So we are solving this one. Two cases we already completed. Okay, we see in the case one. That case one is exponential function e raised to ax plus by. Whenever e raised to x plus by is there, the shortcut method says replace d by a and d dash by b, and we get a pi. We get a pi. Case 2 we already completed, where we seen sine or cosine of ax plus by, sine of ax plus by or cos of ax plus by. In such a case, we replace d square by minus a square, dd dash by minus ab, and d dash square by minus b square. So these things we learned in the last session only. We replace these things and we get some number and that becomes a pi. But now what is the case 3 here? This is the last case for getting the pi in a partial differential equation. Case 3 is used in two cases. The case number 1, this RHS function f of xy is other than this exponential and trigonometry. If this f of xy is, for example, log, tan, cot, sec. Okay, if f of xy is any other function than exponential and sine, then we use the general method. And the other case, when we replace this d by a or d dash by b, or here d square by minus a square, and if that denominator comes to 0. So I will tell you the two important case for the general method. So this general method is used if that RHS is a function of log, tan, cot, sec. Okay, this one. Or when we replace in shortcut method, when we replace and denominator comes to 0, denominator becomes a 0, then we use a general method. Now let me come to the general method. What is the requirement for this method? General method, first of all, we have to factorize that denominator, that we have that 1 upon phi of d comma d dash. Phi of d comma d dash, we have to factorize this function phi of d comma d dash in the form of d minus md dash. Then we can operate 1 upon d minus md dash, 1 upon d minus md dash on that function f of xy with a formula, and that formula is integration f of x. And now we are going to replace this y by c minus mx. So y is replaced by c minus mx. So this function of x comma y become a function of x comma c minus mx, and now this function becomes only in terms of x, and we can integrate it easily with x. And at the end we resubstitute the value of c, because here we are putting y equal to c minus mx. We are replacing y by c minus mx. So this gives us a value of c c is equal to y plus mx, and that we have to replace at the end. So that's the method only. The method is very, very simple. Step number one, find out the factors of phi comma d. This is a function phi. Okay, that phi auxiliary equation we have to write down in the form of d minus md dash, and we have to apply that factor one by one. We'll come to that with an example. Okay. Any doubt in the general method first? Is there any doubt? So question number one on case 3 is on the screen. The question is like this: 4d square minus 4d dash plus d dash square of z equal to 16 times log of x plus 2y. Yes, step number one is similar throughout the LD and PD. We have to find out the roots of auxiliary equation and write a CF. I want the roots first. Do the calculation and tell me the root.
So 2 comma 2.
2 comma 2 is not correct. Not correct. If you do the wrong roots, your CF is wrong and you lose the 2 marks there completely. Find the roots there. That is a very simple thing, isn't it? How to get the roots? First of all, we should replace d by m and d dash by 1. Then we get
1 by 2, 1 by 2.
So 1 by 2 and 1 by 2.
yes, if they are correct, it is a half and half, correct. So you will observe the CF will be like this. First thing we have here 4d square minus 4d d dash plus d dash square equal to 0. We replace d by m and d dash by 1. We get an algebraic equation in m, and when we see it is a 2m minus 1 bracket square, so m is equal to half and half. So it is a repeated root. So when it is a repeated root, we write its corresponding z complementary solution zc equal to f1 of y plus 1 by 2x, because f of y plus mx is a CF, f of y plus mx. So it is f1 of y plus 1 by 2x plus x times f2 of y plus 1 by 2x. This x appeared because that addition should not be possible. Okay, now step 2 is important. In step 2, we are going to compute a PI. And you will observe the RHS. RHS is not a exponential. RHS is not a trigonometry function. As it is a logarithmic, we have to use a general method only. Okay, so we are going to use a general method only here. So step number one, we written ZP is equal to 1 upon that phi of d comma d dash of f of xy. Now phi of d comma d dash we are writing in a factor form. Why it is in factor form? Because we are going to use a general method, and in general method we require a factor as 1 upon d minus md dash. D minus md dash. So what should be the next step? Yes, anyone? Is a factor is in required form? It's not. We want a d minus md dash. So what should be done?
2 common.
Yes, just we should take a 2 common. So when we take 2 common, but it is coming outside the bracket square, so it comes 4. That 2 becomes a 4. That 16 by 4 can be a 4. That simplification we can do it. So that I show you the next steps. What is done here? 2 is taken common. So 2 square is 4 written. So it becomes d minus d dash by 2 bracket square. Now this 16 by 4 is written only 4 there. Now we are going to use that formula. Now it is in the form, see this one is in the form of 1 upon d minus md dash of f of xy. So that's the form. So what is the formula? The formula says d minus m 1 upon d minus md dash of f of xy is the integral of f of x comma y is replaced by c minus mx and dx. That's it. So can you tell me the next step here then? What should be the step for this factor? Out of that, one factor will keep as it is, which is a d minus 1 by 2 d dash. D minus 1 by 2 d dash, one of the factor we kept as it is. Now other factor d minus 1 by 2 d dash we are applying on log. So what should be the term? Yes, anyone? So integral F is in this case log, so it is log only. X as it is plus. Now you will observe we have to replace the value of y. So what should be the value of y in this case?
C plus 1 by 2x.
Y is replaced by c minus 1 by 2x, is it? Because d minus md dash, whenever it is a d minus md dash, we replace y by c minus mx, y by c minus mx. So here y is replaced by c minus 1 by 2x, c minus 1 by 2x. You can simplify that also. You will observe this if you throw out multiply by 2, it is the 2y is equal to 2c minus x. Okay, so we can get the value of a 2y plus x is a 2c. 2y plus x is equal to 2c. So that about simplification, is it? Just cross multiplied, and why we are calculated that? Because x plus 2y we want, the same x plus 2y is there. So what should be written in the bracket then? Because it is log of x plus 2y, and we are going to replace y by c minus, or you should not confuse. Otherwise what you can do it, you can go step by step. No, I will not write here anything. Okay, so let me replace y by that only, c minus 1 by 2 x only. So because of this, there is a 2y, so I'll take here 2 times c minus 1 by 2x. So just we replace y by that is a dx as it is. So next term 4 upon d minus 1 by 2 d dash as it is. Now simplify this bracket. Yes, anyone? What should be the simplification of inner bracket?
Log 2c.
Yes, log 2c only. So xx gets cancelled. Now log 2c is a constant and we have to integrate with x. So what should be integration?
X log 2c.
Yes, x log 2c, correct. Now the method says we should resubstitute. Once we integrate, we should resubstitute the value of c, and that value of c will be coming from this equation only. This equation only gives us the value of c. Okay, which gives us c is equal to y plus 1 by 2x. Okay, that we can replace. C is equal to y plus 1 by 2x, that we can replace here. Or we can get 2c is equal to x plus 2y, that we can replace. But remember, we are going to apply the same factor again. This is again in the same form of a general method, 1 upon d minus md dash, and this already, that c is obtained, this c is obtained by the same substitution. So instead of resubstitution, what I can do it, I'll say by general method again, it is integral x log 2c dx directly. Okay, there is no y to there is no y here to substitute as y is equal to c minus 1 by 2x. So directly we get this one by a general method. Is it clear, or any doubt in this step?
No, sir, not clear.
No doubt. So integrate. What should be the answer then? Integrate now. So log 2c is a constant as it is. Integral of x is x square by 2. 2 gets cancelled. So it is a 2x square log 2c. That's the answer. But last step is left now. Resubstitute the value of c, and if you replace the value of c again, the final answer becomes 2x square log of x plus 2y, x plus 2y, and that is a pi. That is a pi there. That is a pi. So I will repeat the step here. One of the thing what I not done here, if I replace, suppose I replace the value of c here. What is the value of 2c? If from this equation the value of 2c is x plus 2y, x plus 2y. If I replace here, it will become x into log of x plus 2y. It will become x into log of x plus 2y. But when we apply this factor, what happens again? We have to replace that y by c minus 1 by 2x. Same thing. So it again become a log 2c. So I am not replace the value of c. Otherwise, what will happen? You will replace and again you will get this. So unwantedly you are increasing step. why I am not putting the value of c? Because same factor we are applying again. This is the same factor which is applying two times bracket square is there. So whenever there is a bracket square, bracket cube, and you are applying same factor again and again, so no need to replace the value of c. You can put the value of c at the end only. At the end only. I will show you these steps again here. So just 1 minute. So you'll observe this 1 upon d minus md dash, one of the factors applied where y is replaced by c minus 1 by 2x, c minus 1 by 2x. Uh, yes, to remove actually, yes, we are removing the factor 1 upon d minus md dash by this integral formula. Once we simplify, it become log 2c only. Integral of log 2c is x log 2c, and again by this formula, it is again an integral of x log 2c only, and that is the final answer there. And don't forget to write that yc or zc plus zp is a complete solution. Zc plus zp is a complete solution there. Yes, if you have any doubt, you can ask. What is the most important thing in these questions? The most important thing is this one. Just a minute. Whenever the factor is 1 upon d minus md dash, we are putting y is equal to c minus mx, and this entire equation becomes our formula for integration, substitution, and resubstitution there. So y is equal to c minus mx. This is the main thing. For 1 upon d minus md dash, replace y by c minus mx and integrate it with respect to x, and at the end resubstitute the value of c. Because why we are resubstituting? Because there is no arbitrary constant in a pi. All arbitrary constants appeared in a complementary function. If that, okay, right now in partial actually arbitrary functions are there. So once you complete, tell me. There are two more questions on this method. We'll do it one by one. Done? Can we move to the next question then? Yes. So question is on the screen. The question is r minus 4s plus 4t. I'll repeat. R minus 4s plus 4t is equal to e raised to 2x plus 1. Is equal to e raised to 2x plus 1. So at least calculate CF. Yes, anyone? What is the value of r? What is the value of r first?
E square.
Dou 2z by dou x square. Okay. Dou 2z by dou x square. Yes. S is a dou 2z by dou x dou y, and t is a dou 2z by dou y square. So yes, r is a d square, s is a dd dash, and t is a d dash square. Now find out factors. Yes, now it is correct. It is a 2 and 2. Correct. Okay. So the roots are 2 and 2. Again, it is a repeated factor. So 2 is repeated. So its CF is written in this way. F1 of y plus 2x. So here is that f1 of y plus 2x plus x times f2 of y plus 2x. That x appeared. This x is important because it's repeated. Okay. So x f2 of y plus 2x. Any doubt in the CF? Anyone? Okay. Now, what is the shortcut method says for exponential term? E raised to 2x plus y. Shortcut method says we should replace. We have to compute the pi here. Tell me what should be a replacement?
D by 2.
Yes, and d dash by d by 2 and d dash by
1.
1 because it is e raised to ax plus by. If we compare it to e raised to ax plus by, we replace d by a and d dash by b there. Here, we would replace d by 2 and d dash by 1. But whenever we replace this 2 and 1 and suppose the denominator comes to 0, then only we have to use the general method. Okay, then we have to use the general method. That is the difference in LD and PD here. Okay. So in this case, yes, ZP equal to 1 upon phi of d comma d dash of f of xy, that is e raised to 2x plus y. When we replace d by 2 and d dash by 1, yes, denominator is coming 0 there. It is 0. So here we should write in the form of d minus 2d dash bracket square. This denominator is written in the form of that, and we have to apply the general method. Okay. So we have to write in d minus 2d dash. So what should be a replacement for y? Yes, anyone? What should be a replacement for y when we integrate? As a factor is a d minus 2d dash. Y should be replaced by,
C minus 2x.
yes, c minus 2x, correct? That's one here. So you'll observe the same thing is done here only. You'll observe d minus 2d dash bracket square is there, and one of the factors applied at that time. Y is replaced by c minus 2x. Y is replaced by c minus 2x. So it becomes e raised to c only, and integration of e raised to c is x into e raised to c, because e raised to c is a constant with respect to x. So that's one. Again, we have to apply that factor. Again, the same factor we have to apply. So no need to resubstitute the value of c. We'll continue with that. Yes, anyone? Can you guess the answer then? Can you guess the answer? What is the pi? What should be a pi? Yes.
So e raised to power y plus 2x.
E raised to y plus 2x only? No.
X square by 2.
Yes, x square by 2. Because this d minus md dash, this also you have to apply now. So it is the integration of e raised to c x dx. And then you substitute the value. So this will be the answer here. You'll observe e raised to c x square by 2, or x square by 2 into e raised to y plus 2x. X square by 2 into e raised to y plus 2x. So that amount of y, zp, z particular solution. So don't forget to write zc plus zp is a complete solution. Zc plus zp is a complete solution. If you've done this, tell me. We'll move to the last question. One more. Yes, correct, Saitya. We are eliminating. We are actually eliminating is not word. It is actually we are operating 1 upon d minus md dash factor. When we operate 1 upon d minus md dash factor, it happens that f of xy become integral of f of x comma c minus mx dx. Okay. And that's the rule. That's a general method rule. Okay. 1 by 1 we are operating 1 upon d minus md dash factor. So indirectly 1 by 1 that factor is eliminating. Correct. Any other doubt?
सर वो डिनोमिनेटर कैसे ऑपरेट किया सर मुझे समझ नहीं आया.
ये तो फॉर्मूला है ना, तो जनरल मेथड का रूल क्या सीखा तूने? 2 times I told ना. See the rule. Rule says 1 upon, we are not going in the derivation right now, just I am telling you the rule. 1 upon d minus md dash of f of xy is nothing but it is an integral of that function x comma c minus mx dx. That's one only. Is that clear, Swapnil? Who is asking? I think Swapnil, na?
Yes sir, clear.
So that's the rule, na. So to remove this operator, now previous cases we are replacing d by a and d dash by b. That is shortcut rule there. So that way it is a rule of a general method. The general method says when we have to operate the factor 1 upon d minus md dash, okay, or d minus md dash, we have to operate on that f of xy. It is just integration of f of x comma c minus mx dx. That's one that you have to remember. Are you completed, everyone? If you have the doubt again,
Yes,
good.
done, sir.
Done. Okay. One last question on this method. The question is, I will read the question. The question is solve dou cube z by dou x cube, dou cube z by dou cube z by dou x cube minus 2 times dou cube z by dou x square dou y is equal to 2 times e raised to 2x plus 3 times x square y. So again, I want step one first at least. You should find the roots and tell me. Roots of the auxiliary equation you can tell me, and then you can tell me the complementary function also. Okay, side it is a d cube minus 2d dash. I'm asking, no, not correct. I'm asking the roots actually, cycle.
Sir, 0, 0, and 2.
Yes, 0, 0, 2. That's correct. 0, 0, 2 are the roots because you are replacing d by m and d dash by 0. Sorry, d dash by 1, d by m and d dash by 1, and you will get the roots m is equal to 0, 0, I think 1. Is that? So if that are the root, tell me what is a complementary solution there? What is the CF?
Sir, f1y
Okay,
plus x f2y
very good.
plus f3y plus 2x.
Okay, very good. Nice. So for repeated factor, yes, x is multiplied, and for single factor, it is just like that. So I will show you here a solution, and this is the case. We put d is equal to m, d dash is equal to 1, m and 1. We are putting. So it is became we get equation m cube minus 2m square is a 0. M square is common, so m is a 0, 0, 2. 0, 0, 2 are the factors, 0, 0, 2 are the roots. So ZC become f1 of y plus x f2 of y. So plus 0x plus 0x is written, no need to write it. Plus f3 of y plus 2x plus f3 of y plus 2x. So that about a complementary solution. Now we have to move to the PI. Yes, anyone? What are the things that we have to take care when we write a PI? Yes, PI, what should be uh, taken care? There are two terms. What should be done?
We can solve it separate.
Separate, correct. So that is the first thing. As there are separate terms and there are different terms, both are not of same type, both are not algebraic. One is exponential and other is algebraic. So let me find out a particular solution for exponential separately and particular solution for algebraic separately. Okay, for exponential, what we can do it for exponential first term.
Shortcut method.
Pardon?
Shortcut method.
Shortcut method. So tell me what should be that shortcut method? We should replace
D by 2 and D dash by 0.
very nice. Okay, good cycle. So it is a d by 2 and d dash by 0 because we compare it with e raised to ax plus by. E raised to x plus by we compare with e raised to 2x and then a is a 2 and b is a 0. So we should replace d by 2 and d dash by 0 in the first term. For the first term, we get a pi for it. Okay, but for second term, now it is not a shortcut method for us for in a PDE for it. So we use a general method. We should write in the form of a d minus md dash. We should apply it one by one. We'll come to that. So you'll observe the two steps I done here. So first of all, it is separated. You'll observe it is separated there. For first term, we replace d by 2 and d dash by 0. D by 2 and d dash by 0 and we get ZP1. Okay, particular solution for e raised to 2x is very simple here. But for case 2, it is a d square into d minus 2d dash. That is a way we go ahead. Now, as the factor is 1 upon d minus 2d dash, we should replace y by c minus 2x. Replace y by c minus 2x and we should integrate it. We should integrate f of xy by replacing y by c minus 2x. And this integration is done. Can you tell me the next step? There is 1 upon d square left now. What should be the meaning of it? What should be the next step?
Can we integrate it 2 times?
With respect to?
X.
And what about y then? Yes, you are correct actually. 1 upon d square indicates integration of that function with respect to x 2 times, but we have to treat y like a constant. But before treating, we should replace, now we should replace the value of c here only, because next factor is 1 upon d, and that 1 upon d is a different factor. 1 upon d is a different factor than d minus 2d dash. Okay. So previously the factor we have applied is a d minus 2d dash, and that time we replace that y by c minus 2x. Okay. Now for 1 upon d, 1 upon d actually 1 upon d, if you compare with this 1 by d factor can be written as 1 upon d minus 0 d dash. So we can say we can replace y by c minus 0x. So y by c only. So the values of y are different for this factor. For this factor, this is the value of y, and for this factor, the value of y is just constant. Y is a constant, and because of that, we cannot keep this c till end. Right now, only we have to replace the value of c there. And what is the value of c? C is a y plus 2x. So we should resubstitute the value of c as a y plus 2x, and then we integrate this with respect to x 2 times. I hope I'm clear here. So let I show you the next step. So observe the next steps here. So in the next step here, the value of c is replaced here. The value of c is replaced. C is y plus 2x. So that is replaced. And 1 upon d square is still as it is. Okay. Then it is simplified again. It is simplified. And now 1 upon d square we are going to apply it one by one. So 1 by d square means integration of this bracket with respect to x treating y like a constant, and that is 2 times, and you get the answer. That y is a c only. You can do that thing also. You replace y by c and integrate and then replace c by y again. That is also the way. Or keep y as it is but treat like a constant. Treat like a constant. If any doubt is there, yes, you can ask.